All right, this one's kind of tough. Just about everybody who has this on their practice test has asked me about this problem this week. So Jeff definitely seems to be a problem that's throwing a lot of people off. So let's talk about it. One of the things to notice is that the 6r dr it has an r that is exactly 1 degree less than the 3r squared inside the radical. That's 16 plus 3r squared. The fact that it's 1 degree less is really convenient because that's going to allow us to use U-substitution. So watch how this works. If we let U equal 16 plus 3r squared, and we're going to take the derivative with respect to r because that's our independent variable for this. So it's going to be du over dr is equal to, the derivative of 16 is 0, plus 3, we're going to bring the 2 down, so it's going to be 3 times the 2 r, and this is going to be 2 minus 1, and dr over dr, because we're taking the derivative with respect to r, so it's a dr on the bottom. So just like the chain rule, you do it with, you do it with every derivative that you're doing. But in the case of an r, when you're taking the derivative with respect to r, those cancel out, so you never see it. And that's why, by this point in the course, you would take the derivative of this and you wouldn't really give it a second thought. You would just say, well, this is going to be, what's the derivative of 3r squared? That's 6r. But I wanted to go through that whole process to show you that actually, even in the case of this, you're still doing that dr. It's just that it cancels. So what we have at this point is du over dr is equal to 6r. And we want to get du by itself. That's going to be the more convenient approach to these. So we're going to multiply both sides by dr, and then it cancels out. So this is going to be du equals 6r dr. Now that's super convenient because we've already got exactly that same thing. So we don't need to make any modifications at all. We can just directly substitute du for the numerator. And then what are we going to have for the denominator? We had that u is equal to 16 plus 3r squared, so we can just replace that with u. So this is going to be the square root. The square root is still there, so it's going to be the square root of u. And of course we still have this going from 0 to 1. Well, actually, let's take those limits of integration off because that applies to the r. I'm going to leave those off for a minute because right now it's not really formatted for us to have those limits. So let's remember that we are going to need this to go from 0 to 1, but we're actually not ready for that just yet. So let's just integrate this thing. This is really going to be easier if we bring this up and make it u to the negative 1/2, and I still keep the du, right? Because the reason why I'm making this a negative 1/2 is because if something's on the denominator, we can bring it up, and that'll make the exponent negative. And the reason why it's 1/2 is because this is u to the first power inside of the radical, and this is understood to be a 2. It's a square root if it doesn't have anything there. And the 1 goes on the numerator, the 2 is in the denominator. So that's why this is going to become u to the negative 1/2. Now we integrate, and when we do the process of integrating, the integral and the du are going to be used up in that process. We're going to have u, and we're going to have that negative 1/2. We're going to add 1 to it, and it's going to be divided by negative 1/2 plus 2. Plus 1. What am I saying? Sorry. Negative 1/2 plus 1. So this is going to equal u. We could think of this as being like 2/2, right? If we multiplied this by 2/2, that's just 1 in another form, because 2 divided by 2 is 1. And so negative 1/2 combined with a positive 2 over 2 is going to give us u to the 1 over 2, positive 1 over 2. And whatever that number is on the top, we actually have the same number there on the bottom as well. It's easier to think of this, if you were to multiply this again by 2 over 2, the 2 on the top here would cancel with the 2 on the bottom. You could think of that as being like 2 over 1, means the same thing as 2 over 1. So those would cancel out. So in effect, what we're doing is we're taking whatever the denominator has, whatever that fraction is on the bottom, and we're really bringing it up to the top and flipping it. So it was 1 over 2 on the bottom. That's going to be 2 over 1 on the top. So this is going to be 2 u to the 1/2. And what we're going to do is replace that u. So that u is going to be, if you recall, 16 plus 3r squared. So I kind of ran out of room here. Let me clear up a little bit of room. Hopefully you got all that. If not, you can always rewind and pause it to copy that down. All right, so right now we are at 2u to the 1/2, and we're going to change that back to a, this is going to be 2, we're going to change that back to r's, so because we're not using x's in this one, we're using r's. So u was equal to this. So I think we're there now. Okay, and this and I want to remind you about these limits of integration here. This went from 0 to 1. Now I've kept that off because it was in terms of u rather than in terms of r, so I didn't really want to confuse us by plugging zeros and ones into u, because we can't. we have to plug those into r. Those values for 0 and 1, those are going to be substituted into the r. That's what we have to do. So because that's what the original problem had in it, was r's. We made up u as our own artificial variable just to simplify the way that this looks and make it easier to comprehend it. But the real variable in this equation is r. Okay, so we are going to substitute in the values of 1 and 0 into this thing. So this is going to be, and I'll leave 1 in green, and I'm going to make 0 in red. So this is going to be on the outside. We still have our 2. And then this is going to be for the value of 1, this is going to be 16 plus 3, 1 squared. And this is all under a square root. You see how it has to the 1/2 power? I'm going to make that to the 1/2 power. I'm just going to rewrite it as a square root. And we also have now minus, because we're doing the difference between these two values, minus the square root of, because we have that 1/2 there, 16 plus 3, and now we're substituting in 0 squared. Okay, so hopefully that made sense of why we're doing this. This is the process when we have limits of integration. And so what we're going to do now is just simplify this a bit. So we've got 2 times, now 1 squared is 1. 1 times 3 is 3. 3 plus 16 is 19. So this is going to be the square root of 19 minus 0 squared is 0. 0 times 3 is 0. We're just following order of operations here. And 0 plus 16 is 16. So the square root of 16 is 4. And then we distribute the 2. So this could be 2 square root 19 minus 8. I think that's how they present the answer. It's true in either one of those forms, but this one should be I think, what it has on the answer key for you. So that's the process. And, you know, it is kind of complicated because you have a different variable other than x, which is a little bit unfamiliar. You have a square root, which is a little bit unfamiliar. But it's really not too bad because when we do our U-substitution, you know, they actually had the du right there ready for us. In some cases they won't, and I'm going to go over another problem where it doesn't work out quite so conveniently. And so click the link and that'll take you to the next video. All right, I'll see you there.